Alright, Ludicrous Gamers, it's me, Malefios again, and here we're going to be doing a math tutorial. I haven't done one of these before, but I'm going to try it. And I wanted to teach you guys integration. But not just any integration, integration by parts. And not just any integration by parts, but using a shortcut, which you guys should know because it makes life a lot easier. So, if you're in a regular calc class, you probably learned some integration by parts formula that goes like integral of u dv equals uv minus integral of v du. I think that's right. So you probably learned something like that, and you usually just plug in your u's and v's and all that stuff. But there's a lot simpler way that really isn't much different. It's just organized easier so that you can see it better. So I'm going to show you guys that today. So let's say, we do have this u dv type thing, and I'm going to set it up as a table. So I'm going to draw a little table here. And I'm going to put my u's on one side and my v's on the other. And the u side is going to be your derivatives. So your dy, dx. Your v's are going to be your integrals. So I'm just going to draw an integral sign. I'm not really sure what to do there. Anyway, basically you're going to integrate this side and you're going to derive the u side. So I'm going to say, we have u, and then we have u prime, and u double prime, and so on, arrow, and then we're going to have dv, then we're going to have v, and then we're going to have the integral of that. So yeah, but yeah, you get the point. It'll be easier when I actually show you with an example. But basically, now we're going to not cross multiply, but we're going to diagonally multiply, kind of like that, and we're going to alternate the signs here. And you'll see why in a minute, but you can already see the u and the v multiplied there. And that's what we have in this part of the formula. And then, of course, we have the minus here, which we see is in this part of the formula. And then, of course, your u prime with your v here. This, of course, it goes this way because we're assuming that this is the end of the equation. Yeah, I'll do an example. Hopefully it'll make more sense that way. So let's say, okay, we're going to get integral of x. That's pretty easy. X and e to the x dx. Okay, so that is, fairly easy integration by parts problem. So we're going to have our derivatives and our integrals. And we're going to put the x on our derivative side because x is easily, when you can derive it to 0. E to the x you can keep deriving e to the x because the derivative of e to the x is e to the x. So, and similarly with an integral, e to the x integrated is e to the x. So it makes it easy to put e to the x on the integral side. So we're going to do our derivatives and our integrals. So x derives to 1, 1 derives to 0. Pretty straightforward. E to the x. We're just going to copy the number of rows. So e to the x, e to the x, e to the x. Pretty simple. Now we're going to also alternate the signs, of course, like so. And then we're going to multiply across like this. But now the 0, we're not going to multiply it down to anything over here because there's nothing over here. We've ended the table. This is the end of the table. So the 0 has nothing really to multiply to. Now, of course, anything multiplied by 0 is going to be 0, but we're going to, for the sake of the equation up here, we are going to multiply across at the very end. Hopefully this will make slightly more sense in a little bit. But, so yeah, that's basically it. So we're going to write this out now. X, e to the x, minus 1 e to the x plus 0. And that's it. Well, you have a plus c at the end because it's indefinite integral. But that is our answer. It's going to be x e to the x minus e to the x, or e to the x, x minus 1. So this might be a little confusing at first, but let's look back at our equation real quick. We have our u and our v, which is multiplied here like it is in the equation. And then we have our 1 and our e to the x. Now, we didn't integrate it, except we did, in a way, because I integrated here. It's the same, but it's an integral. And the 1, of course, integrated would be x, but we're not dealing... Actually, no, that's wrong. What am I doing? The 1, yeah, the 1 is just part of this e to the x now. It's a constant. So, so when you integrate... Let's say we ended the table here. This is probably really confusing. We ended the table there, and we multiplied across there. This would really end up being this up here. This would be the integral of 1 e to the x dx. The 1, you know, is 1. It doesn't matter. You can actually pull it out if you want, but it's 1. It's not going to change anything. And, of course, the integral of e to the x is e to the x, so we end up with a negative e to the x once we integrate that. And that's what we have here. Does that make sense to you guys? I'm trying to explain this best I can. But basically, this is just a simpler way of writing this without, you know, having to memorize this type of formula. Let's do another example. Integral of... What's good? I always like using e to the x because it's simple, but let's try something that's not... Well, I shouldn't do that yet. X squared e to the x dx. Also simple. D I, that's just stands for derivatives and integrals, and x squared e to x. Now, if you guys want to pause this and try it on your own, you can, but I will work it out for you here. So we're going to have the 2x here, 2, and 0. Right, e to the x, e to the x, e to the x. That's all just integrated. No problem there. Cross multiply like so, plus, minus, plus, minus. Now, x squared, e to the x, minus 2x, e to the x, plus 2, e to the x. 0 times e to the x is nothing, so we're just going to add the c here and not worry about it. And that's the answer. That's what it is. I mean, I'm trying to kind of relate it back to the equation, but that's all you really need to know. And you can kind of see, you know, you have the uv here, and then the integral, this part, right here, and it just kind of keeps going. And it's really helpful because with a question like this, doing it the regular way, you'd have to do this equation twice, I believe, which is no fun. So, yeah, that's it. Just this table is the way to go, I think, and it saves you from memorizing the original equation. Let's do one more. I think we have time. And this time I'm going to do one that a lot of people say you have to use the formula for, but you actually can use the shortcut with. So I'm going to do integral, again, e to the x. I'm in love with exponential equations. Sine of x. Now the thing with this, dx, the thing with this is that you can't, both of these are keep going if you derive them. You know, e to the x will always be e to the x. Sine will cycle through its thing. But what we can say is that we know sine will be back. If you derive it enough times, it will become sine again. E to the x is the same thing, but since it's always going to be e to the x, it's not quite as helpful. You can do it either way, but I prefer to always leave the exponential functions for your integral. So, we'll set the table one more time. E to the x over here, and sine of x. Now we're going to derive this cosine of x, negative sine of x. And you're probably saying this is going to go on forever. And it will if you keep doing that. But we see that this is sine right here, and this is also sine. It's just multiplied by a negative 1, basically. So we can stop there, actually. And I'll show you why in a second. E to the x, e to the x. So now we're going to cross plus minus plus, and this one we're going to go across like we have in the previous problems. So now we're going to write this out. And sine of x, e to the x, minus, because we have our minus out here, cosine of x, e to the x, minus, because there's a minus outside of the sine. And now we're going to do the integral of sine of x, e to the x, dx. And hopefully this should make sense, because as you can see up here, this is the integral. I have so many arrows pointing to this integral. Because over here, when we did the zeros, that really was the integral. It's just when you integrate 0, you don't get anything, you just get a c. That's where that comes from. So, so now we have this. And of course we can't do this. This is the problem. This is what we're asking in the original equation. But the cool thing about that is that this over here is equal to this. So we can say sine of x, running out of room here. Can I scroll over? I can, yes. Dx. So this, they're equal. And these are the same quantities. So we can actually add to from one side to the other. So we're going to add this quantity. I'm just going to write quantity because I don't want to write all that out. We're going to add this from the left side, and we're going to add it to the right side. That's your regular just subtracting from one side of the equation, adding to the other, whatever. So this is actually going to go away, and now we're going to have 2 on this side. So now we have our sine of x, e to the x, minus cosine of x, e to the x is equal to 2 sine of x, e to the x, dx. And since our question is asking for what this quantity is, we can just divide by 2. Divide by 2. That goes away. In fact, I can erase it. Check it out. And now we see that this is equal to this. And that's using the shortcut. Now, of course, this one was a little bit longer than the ones up here, but, of course, doing it with the formula would be a lot longer. So, I hope that makes sense to you guys. If it doesn't, tell me in comments, and I will hopefully answer your questions. And hope this helped if you're doing this in your calc class, and I will see you guys later.